Good afternoon, everybody. Welcome to the Inkjet Theater here at ISA, sponsored by Graph Expo. Great conversation coming up here. So without further ado, we've got UV LED New Digital Printing Possibilities by Sean Liu of Mankind Digital. Sean?
Thanks so much. All right, everyone. Thanks so much for attending our presentation here at ISA. My name is Sean Liu. I'm the Director of Digital Technologies at Eastern Tech Company. We're the makers of Mankind Digital's UV LED printers, as well as Firebird digital inks. A little bit about Eastern Tech first. We're headquartered in Milford, Connecticut. We've been around for 22 years developing inkjet technologies, as well as inks for different specialty applications. We have ink production capabilities of 150,000 liters per year. That's 180 tons. And again, we have UV LED equipment and software technology manufacturing capabilities. All right, our topic today is going to be UV LED. And in order to get a better understanding of it, we're going to start right with the two main bullet points that catch us up to present day. In 2007, the very first commercial UV LED printer was launched to market. This was by Sun Innovations. This company is actually backed by the Russian government, and it was meant to foster development and growth in the nanotechnology sector. They launched a Neo UV LED printer, and it was marketed for printing onto acrylics, foam board, signage materials. This printer is actually still commercially available today. This is only in 2007, not too long ago. The second key event in UV LED printing history was in 2011, when Mimaki launched a UJV 160 printer. This was marketed as a hybrid printer, in which you were able to print onto roll and rigid media. The technology that allows us to print onto both types of substrates is actually the ink. Mimaki calls it hard and flex ink. And Mimaki, with its legendary capabilities in solvent printing, with the consistency and reliability, really stepped into this marketplace of UV LED printing and gave this industry credibility. So these are the two main bullet points, a short history lesson, but it gets us to present day. Take a look at the OEMs that are available currently right now. And many of these companies are actually exhibiting here at ISA. I've taken the liberty of putting their booth numbers here so you could check them out afterwards. A lot of these companies you'll notice already, they're brand names and they're moving into UV LED. Now, to be fair to all these companies and who made this slide, there's many out there, but I searched and put the main companies that made the Google search list for UV LED printing. You'll notice a lot of these companies have many different series and model numbers, and so they largely depend on the print size as well as printer configurations. One other company that made that Google search list was Mankind Digital, and we're here actually launching our large format printer. This is a Xenon printer, 51 inches by 51 inches. There's 7 Ricoh Gen 4 print heads incorporated into this for high volume production capability. We have CMYK for the color pass, 2 white channels for underbasing, and also a clear gloss coat for our spot coloring. Now, this 51-inch printer is a workhorse. We have many beta users already who are printing 3 shifts of 8 hours, so it's running nonstop. And this printer has the capability for signage, printing onto rigid as well as flexible materials. We're just really excited to be launching here, and this machine is actually here in the Inkjet Theater. Please check us out afterwards. Also, we have Mankind Digital has the Neon UV LED printer as well. This is an A4 size printer. We have the capability of printing just under 12 by 24 inches. And it's unbelievable what we're capable of printing onto. We're going to move more into this in our presentation, but we have so many applications in which UV LED is applicable for. This printer has the ability to print 90 seconds for an A4 size print, full color. And of course, this printer is also here at Mankind Digital's booth, right here at 2843 across the aisle. We hope you come and take a look at our printer and capabilities. Okay, let's take a look at what UV LED is capable of doing. This is an application where we're printing directly onto stainless steel. This is kind of a beer opener bottle that we had a manufacturer make for us. This is stainless steel printing. We're printing digital colors directly onto the substrate. We have an adhesion promoter that we can apply for excellent durability and adhesion, but this is full color directly onto the substrate. There we printed CMYK, and now we're giving you a look at this technology where we're printing a white ink underbase first. The reason for that, we're going to highlight the CMYK pass directly onto it. If you look closely right now in the video, we're printing white ink first, immediately followed by CMYK. This technology is considered inline printing, and this is something that we've developed and allows for great registration, as well as great highlight of the CMYK color. One thing that you'll notice in this print application, I'm going to hand a couple of these out. There's actually a textured layer. UV LED is an instant cure technology, meaning the second you're printing that ink droplet onto your substrate, that UV LED lamp comes around and cures directly over it. You're getting texture to it. You can actually, what we call, pin the ink, giving yourself the ability to have a raised texture as well as layers. Oh, and in this video, we finished a great print. We always test for durability. And what better great way to do it than actually open a beer can itself, beer bottle itself. There's great scratch resistancy, and we're going to talk a little bit more about how to measure these effects of quality print with UV LED printing. So, UV LED printing, let's look into the basics a little bit more. What is it? Who is taking a note? What are the applications? And what is the future? We're going to jump into each of these issues in this presentation. Okay, UV LED printing is actually the cross-section of a couple of different technologies. First, we're going to talk about the inkjet printer hardware itself. Actually, very recently, there was the invention of the micro piezo print head. And this electric signal that allows us to jet inkjet droplets allows us to open the floor for UV LED printing. We're also going to talk about the LED itself. This is a light-emitting diode. This diode, along with the integration into a lamp, allows us to be able to cure the inks. Finally, it's the UV LED inks, and this is Eastern Tech's specialty. This is our wheelhouse. We develop inks specifically for specific applications that many of our end users find possible, and a lot of our end users are finding new applications all the time with this technology. We're going to start with the micro piezo printhead to start. A little history on this. In the 80s and leading into the early 90s, the inkjet industry was primarily focused on thermal printheads, or what they called bubble jet technologies. This is where tiny resistors generated heat, vaporizing the ink, and actually jetting ink directly onto a substrate. Now, in 1993, Epson launches what's called the micro piezo printhead. This is actually controlled through ink droplets through the use of currents actually jetting the ink. Now, this has the ability, as you see here, variable size droplet technologies. We're actually able to get these different picoliter sizes to allow for different resolutions, as well as different stocking in our print. So we have better output quality, and as I mentioned, we're no longer using heat to be able to jet the inks. This allows us to use inks that actually have heat resistant capabilities. And what do I mean by that? Taking a look at this graphic that you see here, this is the difference between a piezo and a thermal inkjet printed technology. This is magnified to 50 micron. On the left-hand side, this is piezoelectric. In both situations, we're trying to print a black ink droplet. On the left-hand side, look how close we're able to get that accuracy of the print. On the right-hand side, this is thermal. We're using heat to vaporize inks. Not so clear. Now again, this is the ability for us to use micro piezos where we're eliminating the need for heat on the print head. Allows ink manufacturers such as Eastern Tech Company to be able to use heat-sensitive raw materials in their inks. This opens up the direct-to-garment market. Eastern Tech developed the Firebird digital ink for water-based pigment ink to print directly onto t-shirts. And I'll give a demonstration of this as well. Here in the video, this is a water-based pigment and ink printing through a micro piezo printhead technology. What we're doing again is that inline technology. We're laying down that white ink underbase right before CMYK. Previous to this was never possible with the inkjet technology that was available through thermal printheads. This is only opened up through micro piezo. And again, this only started in 1993, and this allowed us to open up the UV LED market as well, which requires an electric current to print the inks. These are the final prints, and we're handing out a shirt to show you the application itself. Now, light-emitting diodes. This is the second component of the integration of technologies. LED is actually a light-emitting diode which comes from a semiconductor. It's a semiconductor that has a PN junction where the current goes from the anode to the cathode. And in doing so, it generates energy in the form of photons. This effect is called electroluminescence. And when this happens, it's this energy that we're sourcing with these LEDs that allows us to cure the inks. We're using that energy to immediately set the inks and pin them onto our substrates that we're printing onto. Now, the key word that I just mentioned is semiconductor. And LED is a semiconductor, and the semiconductor industry invests more than $53 billion in R&D in a year. Essentially, we're riding their investment wave. LEDs are becoming more efficient and and more cost efficient every year. In fact, LED efficiency and light output doubles every 36 months, in which I'm calling a Moore's Law parallel. In the semiconductor world, it's 18 months where we get double the speed and efficiencies. In LED industry right now, because we're riding their coattails, we're getting 36 months, we're increasing the output in technology with LEDs. So this technology is not going away. We're backed by a great industry. LED is gaining share as well. Previous to this, there's only UV mercury halide type of UV curing technologies. Well, LEDs have these advantages. They're compact, they're lower cost of ownership. These things last for over 10,000 hours of life, and they're consistent. You're not going to get degradation over those 10,000 hours of life. It's environmentally friendly. It's in the UVA spectrum. You don't have to be standing there necessarily with glasses watching them. This is a very safe technology, and it's a small footprint as well. You're able to put this right on your print shop space and not have additional fume hoods or things to work away toxic fumes. These are the benefits of UV LED, and it's only getting started and taking over the traditional UV mercury halide type of technologies. Here's a look at the market itself. From 2002 to an estimated 2017, UV LED technologies are going to take over. It's in 2012 we had 12.7% of the market share, moving into close to 34.7% estimated in 2017. UV LED is here to stay again, and it's only going to get bigger. Okay, ink innovation. I love talking about this because this is Eastern Tech's specialty. What is UV LED ink? Well, it's primarily a monomer and oligomer-based composition. A monomer is essentially a small compound or molecule that has the ability to combine with other molecules to create an interlink. This is the ability for us to essentially create small molecules, big molecules, all through the use of the UV LED lamp kicking off this reaction. The items that we include in our ink that kick this off is actually photoinitiators. These are compounds in which once the UV LED has that electroluminescence effect, that energy gets imparted on the photoinitiator, kicking off this reaction with the monomers and creating a crosslink. This allows us to get great super adhesion onto our substrates, as well as long durability and weatherability. There's another part of our ink, it's the additives component. This aspect of our ink has the ability to control different features. Do we want a gloss look, a matte look? Do we want the inks to have certain properties with flexibility? These are additives that we have to enhance the ink. And these are the levers that we pull in our lab every day to make sure that we have the right application output. UV LED, how do we measure its performance? We want to instantly cure. We want great ink flow. Again, we have companies that work with this technology 24 hours a day. We want the inks to continuously print without interruption. Color output, are we getting the right color match? Are we having the right pigments to be able to make sure that the color output is where we need it to be? Especially important in signage. Maintenance, how is the uptime? Does the ink require any post-curing process? Anything in addition to what we need to do to print? We want to minimize the challenges to get the print and the accurate print results. Finally, here's something we also focus on specifically. There's a narrow range of curing as well. Once the UV LED emits its energy onto the ink, we want it to set. But outside of that, if the inks are exposed to the ambient light, we do not want it to cure. This is a trigger that we have controlled in a very tight range, and this is something in our ink development that we find that it's important for end user application. All right, quality metrics. Again, adhesion, durability, weatherability. All the people I met asked these questions. Does it last? And the way we have tests for that, we could get into that. There's a scratch test. There's actually an official ASTM test that tells you how to scratch, how you cut it up, how you use tape to peel it off. Basically, in our office, we just take our thumbnail directly to it, see if it lasts the initial test, and over time, does it stay on there? Functionality. Are we printing out the flexible or rigid substrates? These are things that we want to pinpoint. We ask our end users directly, what application do you want? We need to match our ink set directly to what the end purpose is. Finally, safety and environmental. We want to eliminate the need for using solvents and other toxic sort of ingredients. We take it upon ourselves to only use ingredients that are already specified by CPSA to be able to work well and work in any environment. All right, so who is it for? If you come from the digital technology side, whether you already own a UV printer, mercury halide curing, you own a solvent printer, dye sublimation, UV LED is the next evolution into this step. Manual technologies, if you're a pad printer, if you're silk screener, heat transfer, this it might be the time and opportunity for you to move into digital technologies. UV LED, as I mentioned, has a small footprint, it's safe, and it has ability to print onto more materials, substrates, applications than was ever possible. Finally, there's new entrants, specialty applications. We have folks coming to us all the time. Can we print onto this? We're doing this application. UV LED makes it possible for many of these situations, and I'll show you what the new future involves, new applications that we've developed in our lab. Again, here's a broad range of industries that people come from: commercial signage, awards, packaging, interior designers, point of sales, a specialty. There's more than we could think of that we could fit on this list. We want to focus on the specialty right now because we want to give inspiration to everybody about what is possible with UV LED. Let's jump right into it. Here's our printable matrix. Do you have the need to print onto acrylics, aluminum, whether it's anodized or raw, ceramics, crystals, PVC, polystyrene? It's all on this list here. We've successfully printed onto all of these materials. In fact, some of the more difficult to print onto materials such as stainless steel, metals, tiles, we've developed in-house an adhesion promoter, which we could directly wipe onto glass, metals, ceramic tiles right before the print application. It's as simple as wiping it on and then directly hitting the print button to get that excellent durability. Previously, there's never been a digital print possibility to get onto tile in the quality that we wanted. UV LED makes that possible. For flexible materials, we're printing onto canvas, EVA foam, substrates such as flip-flops, for example, is one end-use application that we have. Fiberglass, leather, flexible materials. We have a different ink set to be able to print onto these applications with UV LED. All right, let's take a look at print onto glass. So UV LED application here, you can see as the printhead carriage is coming directly across, we're jetting inks onto the glass, and that UV LED light that you see there as a blue light is curing directly over the substrate. And that's an instant cure. After this is done printing, you can immediately package it and send it off. This is ready to go. Excellent adhesion, and there's no additional steps. Here we have a process where we printed the color that you saw in the video, followed by a white intermediary base, followed by another passive color. This step allows us to have different interesting glass applications, which I'll pass around now to show. On our UV LED ink focus in our labs, in our development, we've been sent many samples, very interesting applications in the field. We're going to take a look at a couple of them right now. Since we're able to instantly cure, there's the ability for us to print raised textures onto our substrate. Here we have an example of Roland's Versa UV printer that has the ability to have actual ADA compliant braille printed directly on. Some might call this additive manufacturing and captures almost onto the 3D print market here. We're able to print braille, which is a great add-on for signage applications. And we could send another sample over here as well to show. Now, I just mentioned 3D printing as well. This is really a new embarkment onto digital printing. UV LED allows for this allows for instant curing. So after you print that first pass, it's immediately set cured. You don't have to treat it at all. That allows for us to immediately send the second pass, continuously printing the same pass over and over again, building layers one on top of itself. This is called the layering effect that we're including, and it has the capability to print, as you see here, in only 5 passes, 7.2 millimeters in height. We could continue this process to build more and more layers upon layers, giving us more of a 3D element as effect. This is something very interesting to consider, and I think this technology will only become more advanced as we go further along. Speaking of which, we have the ability to print onto thermal plastics as well. This includes ABS and PLAs. This is, as everybody knows, a MakerBot is a 3D printer. Well, a 3D printer only has the ability to print with one filament at a time. So you're choosing, even here in the slide in the bottom left, you're choosing one color out of all of them. Even though they have many colors, you're only extruding that one filament. A lot of times the final product is what you see on the bottom right. Really interesting prints, but it's one color. Well, since we have the ability to print onto thermal plastics, we could decorate this 3D print. Here I have as an example, this is actually a 3D printed object, and we could print directly onto it. And we're going to consider this as a 3D complement of color. If you have a MakerBot, for example, or any 3D printer, combined with a UV LED printer, You could print your 3D object, whatever that might be, and then immediately add color onto it, full color as you see here in the sample being handed out. I think there's going to be more advancements in this technology field as well. Okay, a patent pen that we have for Eastern Tech Company. We're really proud of this. It's a glass etch relief. So printing onto glass, as I mentioned, is very difficult. But also there's an etch effect that many award show type of shops would like to offer. We developed a glass etch resist. We're printing our UV LED white ink, a specially formulated ink, directly onto glass. And on it, we have strong adhesion. What we do after that is we apply a etch-all product. This is commercially available at Home Depot, Joann Fabrics, and wherever the relief was printed, it serves as a stencil. So we're applying the etch and etching whatever is on the glass, leaving the etch possible. Now, what's patent pending about our ink is that it's easily washable after you apply the etch. This same technology can be applied to printed circuit boards, where we're fabricating circuit boards now. This is a very difficult manual process typically, almost silkscreen on there in the market. You could instantly create circuit board now with our UV LED application with the same process of creating a relief, a mask, using ferric chloride to create the etch onto copper-clad boards. And again, just simply putting it under the tap water in your sink, you can wash off the relief as well as the etch all in one. You can see in this slide here, we're creating leads of down to 7 mil. This is remarkable if you think about it. Just because we're using this piezo printhead technology again, we're getting this fine dot gain on here, fine resolutions. We're able to create applications such as PC board fabrication. So UV LED inkjet printer metrics. What are you guys looking for when you're walking the show and you're talking to the OEMs out there? Well, essentially, you're going to look to see, first of all, is it big enough? Do you have the printable area size that's big enough? Mankind Digital has an 11.5 by 24-inch board. That might be good for many of the small signage, interior signage applications. We also have a 51 by 51 board application, our new Xenon printer. And that might be bigger for longer runs or more of a production-oriented environment. Resolution, you want to know what kind of quality you're able to obtain. And a lot of this will depend on the print head. That's a great question to ask the OEMs. What print head does this incorporate? Production speeds, what is your output? Maintenance and troubleshoot. This is your time. These machines are complex systems. You do need to figure out what is involved with the machine beyond just printing. You do need to know what the upkeep time is because, again, that trickles down to your bottom line. Speaking of your bottom line, the ROI, you want to figure out what the base price on these printers are and also the ink costs as well. Mankind Digital, we offer these machines very affordably. Our neon UV LED unit is offered under $20,000. And in addition to that, we're the ink manufacturer as well. We offer the inks directly to end users, and it's very cheap and the cost per print per item. There's a learning curve that's involved. There's definitely training involved. You need to understand what's involved with learning the software, the operation of the equipment, and even, again, the maintenance. In-house technical and graphical expertise. Is your team set up to be able to operate this equipment? You need to have basic understanding of Photoshop or CorelDRAW, art rendering software to be able to even load up the graphics to get great output on these machines. Throughput and workflow of the printer. Do you have the business to begin with? These are questions you need to ask. Do you have an application that you can immediately apply to UV LED printing? And technical service and warranty, are you working with the right company? Are they going to be able to follow up with any issues that might come up in the field? And issues will come up in the field. How good is your OEM going to treat you when things go after the sale is made? All right, so during the show, everybody should have a textured card, an ROIO example that you see here in this graphic. The clear PVC that we sent out that we actually printed on was 10 cents each. We're able to actually fit 16 of these on our neon UV LED printer. Now, the print that you have is really cool. We printed on both sides, and it's actually 3 jobs that we sent. The first job is actually Spider-Man itself. We printed the white ink underbase, followed directly by the color pass. This pass itself took 1 minute and 1 second to print, about 4 seconds per piece, and it cost 18 cents each of ink. The second pass we printed on the back side, just a CMYK. You can see the cityscape. And then again on the back side, we printed another layer of white, followed by another layer of CMYK to print the cityscape, so you can see it on both sides. Now, the total cost of this was the 10 cent for the card, 40 cents for the ink cost, 50 cents per card, and it took less than 3 minutes to print the 16 cards. Here's your costs. What's cool about our software, you can actually get a sense of what the total cost and the total time to print is, even before you actually send it to the print job. As it's highlighted here in the red circles, the ink coverage, it calculates how much ink it required to lay down the job, as well as the printing duration, what time you could expect. So you can make decisions. Is this print job worth my time? Or how can I price this print job if a customer comes in, brings a graphic, and wants us to print this job? So you have the ability to have decision-making power before you actually print. And that's a feature of our UV LED software. The ink coverage in this total print, the very first front Spider-Man, for example, I broke it down. It took 13.16 milliliters of our ink at about 0.225, 22 cents per milliliter. Our inks are $225 per liter. The total cost would just be 18 cents. And this is all readily available in the software side and our costing data. All right, so we have another stainless steel example of the ROI, the one that we saw in the video, and also we handed out as a sample. This ink coverage was just 3.38 milliliters. At the cost that you spend for the inks, it's just 6 cents of ink for those bottle openers to create. And again, we did 2 passes with a texture layer underneath, followed by the CMYK. The conclusion of my presentation, UV LED printing is the convergence of multiple technologies, from the inkjet hardware itself, the micro piezo printhead, to the LEDs, to the ink, UV LED ink, all of which are growing and all of which are experiencing rapid growth and development. UV LED printing is also environmentally friendly, low energy consumption. We just mentioned the quality that we can obtain with this, and printing onto a wider variety of substrates. It's worth looking into, and it's worth considering how it could be incorporated into your business. The additional resource that we tapped into is UV LED forums. You could look into this site as more. This is an open forum discussion about UV LED printers. Many end users are in there talking about their equipment, as well as many of the actual machine manufacturers as well. So join the conversation there. And that is it. I thank you guys all very much for your time. I'll be here in the Inkjet Theater, as well as our booth 2843 just across the aisle here, showcasing our printers. And I would certainly love to help answer any questions anyone might have. Thank you so much for attending.